Hi, I'm here to talk to you about number 5 here, extreme events, including rain, flooding, weather, things like that, from your climate change project topics. If this is the one you chose, this video is for you. I'm going to look at each of your 4 sources in order. I'm going to kind of help you understand this a little bit better so that you can do a really good job with your project and answer all your questions. Here we go. So this is NASA's Global Precipitation Measurement Center here. So we're going to be tracking trends and patterns kind of in your global rainfall. Okay, so at the very top here it says the distribution of the world's rainfall is shifting as our climate changes. Wet areas are getting wetter, dry areas are getting drier, storms are more intense. This is causing more chaotic weather, right? So I covered this already in one of my videos, but we're going to look at it again just because I want you to understand. So according to an intergovernmental panel on climate change, an increase in the average global temperature is very likely to lead to changes in precipitation and atmospheric moisture, which will shift the precipitation during storms. So there's a lot of jargon in here. So as the lower atmosphere or the troposphere becomes warmer, evaporation increases, which puts more moisture in the air, basically. When there's more moisture, there's more intense precipitation, triggering more flooding. And in other areas, warmer temperatures may lead to increased drying, which would accelerate drought. So, hi, California. So to predict future changes, scientists are using very sophisticated computer models to kind of figure out and relying on the data that we've got now to kind of describe what might happen in the future. So looking at this graph, we're looking at, this is the average rainfall in millimeters per day kind of across the world from 1998 to 2011. You can see that the tropics are going to have most of your increased rainfall and stuff, but you're seeing it start to kind of measure out up these kind of paths where there's good air, or there's specific types of air circulation and things happening, so that you're seeing there's more precipitation in some of those places, which that's kind of all this one shows, right? So the big reason that I want you to be here is to kind of read some of this information and kind of understand that, yeah, okay, so there's these connections. Warmer, more evaporation means more water in the air, means more precipitation, means more flooding, means more extreme changes in precipitation events. That's kind of what this page is all about. So that's more of the like, what does it mean, and not so much of the how we got there. So I mean, how we're really getting there is by being able to measure those things. So we can measure the amount of moisture in the air. We can measure the amount of rainfall. We can count how many extreme events like hurricanes and massive flooding events and things like that are happening and their effects. And we actually have seen in a human lifetime that the effects are getting more substantial. Okay, so that's kind of your first source there. And let's look at the next one here. This is the extreme weather page from the NCA 2014 study. For some reason, the UI is kind of whacked out, but you can see here there's overview, report, findings, regions. We don't really need to mess with these too much because we're already in the right place. Extreme weather. So some extreme weather and climate events have increased in recent decades. There are newer and stronger evidence here that's confirming that some of these increases are caused by humans, related to human activity. So we're going to explore extreme weather by coming down here. Here's an introduction. Tells you a lot about what you saw in the first one. Here you can see some data on heat waves. So this is pretty much counting the 100-degree days. So if you look at this graph here, the number of 100-degree days coast to coast. So in Ohio, we've got less than 10 in a year usually. Now, that's not entirely true. I think that, this is from 2011, right? So 2011 was pretty chill for us. But lately, we've had probably more than 10. So we would have been this lighter yellow color, 100-degree days in our summers, right? So you can see there's some places that are drastically affected by this, have lots of over 100-degree days. This is from 2011, like I said, but it's just there to help you see. You can look up that graph from pretty much any year if you just type it in. Drought, right? Drought's when it's really dry. This tells you that higher temperatures increase evaporation, so there's going to be less moisture that's on the ground, and that can be bad. So that's bad for your soil. It's bad for things growing. It's, not great for us either if we need water. So hotter summers, drier conditions when there's more of that. So less water in the soil, right? So that lowers the heat capacity of the soil. That's not good either. So here you can see Texas summer 2011. On the y-axis, you've got average temperature in the summer, and then on the x-axis, you've got average rainfall in the summer, right? So not very much rainfall, massively high temperature average, and then when there's lots of rainfall, not so much, right? So you can see that this data doesn't like have a trend where it goes in a specific direction, but 2011 was bonkers for Texas. It's just really dry and really hot. So those things are related, and you can kind of see that where it's wetter, it tends to be not as hot, and then when it's drier, it tends to be more hot. So 2011 was a special year, but it is there to help us kind of visualize that. Okay, heavy downpours. So places that do get rain are getting a lot of rain, a lot more rain than they usually get. right? You can even tell that here. Like recently in my neighborhood, we had rain. It was so bad that like everyone's basement flooded, and people were like putting their carpet out and stuff on the sidewalk to get rid of because their basements were ruined, and that hasn't happened since they've lived in the house. Maybe they've been there for 30 years or 40 years or whatever. So that was a pretty heavy precipitation event. So we're starting to see more of it. And here you can kind of see that relative number of extreme rain events, right? So in the early 1900s, not so high, but then really high for some reason in the 40s, really low in the 50s. But you can see that since the beginning of the 60s, late 50s, it's kind of trending upward, right? Increasing drastically in the 1900s and even more so in the 2000s. So something to look at. And then here you can see the mechanism driving these changes is well understood. Warmer air can contain more water vapor than cooler air. Global analysis shows that the amount of water vapor in the atmosphere has increased due to human-caused warming, right? How are humans causing warming? If you want to know, click those links, or look at some of my other videos, or stay tuned for people's projects that are coming out, right? They're going to tell you all about it. So we're going to kind of piece this all together. Flooding tells you a lot about the types of floods. You got your flash floods, you got your urban floods, you got your river floods, you got your coastal floods. You can kind of see how that works. Coastal floods are related to storm surges from hurricanes and other things, right? River floods have to do with so water from one area flows into a river. So we've got like the Scioto or the Olentangy, that you guys probably are more familiar with the Scioto, but water from our area flows into our streams and channels and then down into that bigger river. And when there's lots of water in that area, the river is higher, and that leaves the banks and it goes flooding about, right? Urban flooding happens like in your neighborhoods or in your cities when you've got lots of pavement and places that water can't go through, it can't leave. And if you remember from the stream table lab, that paved surface increases the water flow, right, which can increase erosion and things like that. Flash flooding occurs in your smaller areas like your creeks and streams. So your parents are probably telling you things like, if it's raining really hard, don't go play in the creek because you never know, right? Flash floods happen that way. So yeah, and then here's more talk about hurricanes. It'll talk to you more about like how frequent hurricanes are, what are some of the things that are happening from hurricanes. Here you can see damage caused by a storm surge, which is pretty insane. You can see there's some projection for the end of this century. So at the end of the 2000s, what might happen, right? So greater rainfall, more hurricanes in warmer climates, increase of 20% where places with hurricanes get that. And then change in other storms, your heavy snowfall events. So believe it or not, warmer weather actually leads to heavier snowfall in some places. So it's pretty nuts. So you can kind of read through this and kind of see how it goes. This is actually, I think, pretty easy to understand from your perspective. Like, it's not using a ton of like weird jargon or terms, so it's pretty user friendly. And then down here at the bottom, if you wanted to click and go to future climate, you can kind of see what we think the climate might be like in the future based on this study. It might not help you for your project, but it might give you some insights into future for the climate in general. Okay, we got 2 left. Let's do it. Climate.gov, extreme event attribution. That's basically saying that, like, are we saying that climate change is happening, or is weather just weird right now? So here you can see this is a picture from Puget Sound in Washington. This is basically the Pacific Ocean washing up onto somebody's street. So normally that'd be pretty cool to be near the Pacific Ocean, except for when it's like in your yard now. So that's not good, right? So this is kind of looking at, we've been looking at evidence in places that, increasing global temperature is actually part of the cause for this. So this is going to kind of explain that for you. So it's written by somebody who's acting like a smarty pants, so it probably sounds like it's kind of hard. But what's important is these highlights over here. All extreme events have multiple causes. Not every extreme event is just because people cause the world to get warmer. But people causing the world to get warmer is one of those things, right? Extreme events can be attributed so we can figure out whether global warming made an event more likely or more severe, but it can't tell us if global warming caused an event. Right? We can't be like, oh, did Hurricane Irene happen because of global warming? We can't say yes or no. But global warming or global climate change could have increased the opportunity for that to happen, right? So extreme events related to sun and rainfall are easier to study than things related to fires, droughts, and tornadoes because, like, any John can go out and start a fire. And sometimes it just gets dry places, and tornadoes are kind of hard to predict as well. But rainfall is a lot easier and things related to the sun because we can measure that. So it's basically, this article is pretty much just saying, like, yeah, we can't say for sure that all these events are caused by that, but, like, sometimes we can say that it's probably all related, right? And so here are some pictures of this place called Panini Bay after Hurricane Sandy, and then here they are moving this building, this restaurant, elevating it, prepared for future flooding. This is kind of like if you go and you look up pictures of the Outer Banks, North Carolina, you'll see a lot of the buildings are like up on stilts, or they're moving them because the shorelines are going away and things like that. So these things are related to this climate change situation. And if you want to look more at this, right, you can kind of see heavy rain events in the Gulf in the summertime how has global warming affected them. So you kind of see that, like, these graphs are kind of comparing the difference in average number of years between events and then your 3-day heavy rain total in inches, right? So now our number of years between big events is less than it was in 1900, and now there's more rainfall in heavy events than there would have been in 1900, basically. So we're increasing the risk and we're increasing the intensity. It's not causing them necessarily, it's increasing the risk, it's increasing how bad it is, right? So that's kind of what this site's all about here, what we're talking about. So you can kind of look at this, and this is going to help you kind of look at, like, why is this not a yes or no question, and how does this all work? You don't really need to dig into this, honestly. I don't really think it's important that you look at all this data. It's like really, really long. It talks about this attribution and stuff. There's like all this crazy nonsense in here. I mean, it's not crazy or nonsense. It's really good, but it's long and it's kind of hard to understand. And the key is that you kind of understand that, yes, climate change caused by people is partially responsible for some of these events. And then one more site here. So here's your World Resources Institute. What's climate change got to do with extreme weather? This is kind of going to explain that in simpler terms. I would spend a decent amount of time with this site, just kind of like looking it up. Remember, this is from 2017, so when it says, I just saw a thing where it said last week. Okay, sorry, I missed it. I just saw it again. Oh, in the last few weeks, here's what we've witnessed, right? So these are now old news, but these are things that are happening every year. So it kind of gives you some information, talks to you about what the president said back in the day, talks to you about what the EPA's administrator has said about climate change, whether it's real or not. Essentially, what was happening in 2017, what's still happening today, is there's people that are saying climate change isn't happening. It's not caused by people. And some of those people are in charge of our national agencies on caring about climate change, and that's tough. So that's kind of what this project is all about, is for you to kind of understand. So down here, what does climate science say? What are the scientists telling us? Well, what's happening with heat waves? What's happening with floods and storms? What's happening with fires? How can we relate these things to climate change? So this is going to kind of help make a lot more sense, I think, to you guys. Like I said, there's another source on here that I think this one is quite good for you guys to read through. I think this is where you should spend a lot of time. And then this last source here is also going to be quite good for you to kind of like put it together. In terms that you might understand, or using examples that you could understand like better than just like some scientist going blah blah blah, listen to all this smart stuff. Okay, so good luck with that. If you got questions, let me know. This one is kind of tough, so I'm here for you if you need me. Just, you know where to find me. Send me an email.